So good morning. I will try to present a little bit what we're working on still at the Institute. As Daniel said, we were still left behind a little bit, to say, with C++ router, still working on research after C++ router went more and more for commercial endeavors. And actually we kept on working even longer after that, but it might not have been visible. So we kind of stopped a little bit directly working on open source IMS code around 2008, 2009. So when IMS comes in the market, our job is a little bit done, so we have to move on. But this new platform is actually, I would say, a sort of a sister platform of the C++ router. So we kept on working on that fast prototyping idea that starting in '99, I guess, with C++ router. So the OpenEPC platforms and so on are still somehow related to each other. Then you'll see a couple of logos actually on these slides. So yes, I'm still, even today, still a full-time Fraunhofer employee. So I still have my research team in there, but in parallel we also started a spin-off company as between 2008 and 2013. We got actually pretty far with OpenEPC, so we are now looking at pre-commercial development. So today I want to talk a little bit about telephony, because we're at Kamailio work, so this is the topic, of course. And how does it work, and how can we actually make it better, hopefully, with using SIP, IMS, maybe to support also legacy, so to say, and in a way to actually drop all the legacy that is a little bit heavy. So we also have some demos outside, so you can see that it's not just some R&D's ideas, but they actually work. We try them out. What are we doing then at Fraunhofer Focus? To put my work a little bit into context, we are working on this future seamless communication playground. This is how we call it, Fuse Echo, and we also have some, maybe some major events, similar conferences in November that we run here in Berlin, and actually from this year we're going to have one in, I think it's in June, in Bali, of Fuse Echo Forum Asia. So actually this concepts of prototyping for the telecom industry has been very successful. It promotes openness, so to say, and what we're trying to do is to really have prototypes for everything that we are working with, so that if we come to you and we say we want to do research for 5G now, okay, we're going to have a prototype for that. We're not just going to be talking theoretically about what's going to happen and so on. And we're trying to make them comprehensive so that you have all the components in one, in one place.
Excuse me, do you have any mobile in your pocket? Do you put it on the desk or maybe
far away? That's it. So we're trying to provide all the functional elements in one. Of course, we are still trying to keep all the interfaces, and we have all the interfaces available, so you can then use your own and plug your own in the test beds. We're only targeting test beds in technology trials. We are not really targeting real life deployments with this, but we're here so many years later after trying the things with C++ router and so on. So there is actually a very solid base to this, and they can go even further. Everything is driven by demand. So everything that we get in there is not in there because we found it in a standard or something like that. We find actually that pretty bad as a strategy to implement, so just because it's in a standard. So instead of that, we're trying to say, okay, if you actually commit to this and you want us to implement it, we'll do that. Otherwise, it just dies, with the standard. And we're always going for just 90% of the standards, so to say, with 10% of the costs and the efforts. So this is a difference between having just a R&D prototype and a real-life product. So it's always we care more about functionality versus stability, for example. We're not really interested that much in super high availability. But we do have actually decent performance based on the same platform, so you know what to expect. We are building some basic recovery mechanisms and so on, so that you can do field trials with thousands of users without any issues. There is no 100% compliance claimed. We don't, go for real products. And in the end, we say, there's nothing wrong with not actually having a product because it gives us better flexibility to try crazy new things. Or if that's not enough, this is why we made a spin-off company for those of you that would actually want to deploy this commercially and need to go the extra mile. So I want to talk about this Evolve Packet Core a little bit, and this is the whole architecture, all the functional elements. I think there are about 15 of them. This is the platform that is supposed to support 2G, 3G, LTE, also non-3GPP technology, so like Wi-Fi, WiMAX, and so on. And it's mostly targeted towards providing packet switch services. So an IP connectivity layer, if you want, a seamless IP connectivity layer. Of course, you still have to care a little bit about legacy. So today I want to talk about the MSC. This is the legacy that you have in the network. This is the functional elements that provides you with telephony in 2G and 3G. Of course, for LTE, you don't care that much anymore because you don't have CS legacy anymore in there. So if you want telephony, the answer is relatively easy. Go for IMS. But in reality, that if you have an LTE phone today, you probably are not doing IMS. You're doing other things, falling back to the MSC and so on. So today I will try to concentrate on those, so just touching the telephony part of the architecture, not the IP connectivity and so on. This OpenEPC project, I already mentioned, started around 2008. By the time that we actually stopped working on the open source IMS core, as research died for that, this is not open source, unfortunately. So I hope the name is not too misleading. We call everything that we're doing open something. We have an open MTC for end-to-end, open lots of things. Open as in all functional elements, all interfaces, all protocols implemented, no vendor locking, no things like that, and we're also providing source code to our customers. So I would say that we want to be a sort of a different breed of small telecom technology providers that instead of providing a closed box and so on, we go to our potential service providers and operators and say, hey, this is it. You can get the source code, so then you can customize it as you wish for yourself. We wanted to make it open source, so we also considered that. But then, it did work for the open source IMS core because we had 4 functional elements, so 2 full-time employees, 3-4 students. We could finance that by selling IMS clients, IMS application servers, prototypes, and so on. Now looking at EPC, we have 15 functional elements. You have a truckload of 3GPP protocol stacks. So it's not just, hey, we have SIP, RTP, 2-3 protocol stacks, and that's pretty much it, and also diameter. But here, the complications for 2G, 3G, you would not believe, the whole huge protocol stacks and what went in there. So the team actually was composed of more than 10 full-time employees, 10 other students, so on average we had about 15 people working on this for the last 5 years. So then it's very hard a little bit, to still pay all these salaries and go for an open source model. Still, we share a lot of things. So, for example, when we are developing some modules, and those are also used in open source IMS core and so on, you might have seen this in Kamailio. So, I think the offline charging module, it's still there, should still be usable, diameter and so on. All these modules, we are actively developing them in EPC, but sharing everything with the open source community. In 2013, end of last year, actually, Franco stopped working on this, so to say, and we started there concentrating more on the crazy things, Open 5G Core, but that's still for next year to come. And what this does is that it provides this IP connectivity layer between base stations and so on, so your actual radio access network and transparent applications and services on top. IMS is one application, so you could use IMS and it has a very nice integration, but any IP application would work. It does not need to be deeply integrated with EPC. Same principles as for C++ router, everything runs on Linux and standard x86. That's our main platform, but you'll see the demos actually, we show it on a Raspberry Pi and so on, just to showcase that it is flexible and it doesn't need that many resources to run. And everything works with standard femtocells, small cells, for example, base stations, regular phones, modems, and regular SIM cards. So it's not that this is just an emulation, but it is actually a real prototype implementation. Now, to get to the subject of my talk today, going a little bit for legacy. This is how the 2G telephony stacks are looking like. And first of all, we have to notice this GSM layer 3 that does mobility management, call control, SMS exchanges, and so on. These are the protocol stacks towards the client. I'm not going to talk about the ones towards the core network, so I don't want to touch SSL and IN and so on, because we entirely scraped those. We don't need those to actually provide these services. So this is a protocol that is, these are the protocols used between the mobile devices and the first hop in the core network, the mobile switching center, the MSC. So we have that GSM layer 3, and then, well, it looks a little bit ugly because what you have here on the bottom are relatively old protocols. So you have today lots of cells and so on that obviously support IP because otherwise you couldn't deploy them anymore. But it's still that these protocols are really not formalized. Some of them are maybe non-IP, but there is no formalization on these protocols, and most of the cells and so on would use something proprietary. Same for the media stack in there. So I just put as example this MGCP RTP because this is what some cells are doing, are providing for practical reasons, but these things, typically is transported over ATM, so you don't have a guarantee that you would have a different protocol stacks in here. Nobody cares anymore at this point about defining new protocols for 2G. This is a very old technology. It's being phased out, but still we're not going to be able to turn off 2G anytime soon due to coverage and so on. So it's a strange thing that happens in the market, that we're still keeping a lot of this legacy, but still in parallel trying to phase it out. For 3G, things are a little bit better because 3G has been defined from day one with both legacy, so technologies, and IP transport. So this looks better, and you can expect better compatibility from the cells and so on. Fortunately, we have the same GSM layer 3 on top, so then from the connector perspective, it's pretty similar how you handle telephony with 2G and 3G. Unfortunately, you have huge stacks in here, huge things that you won't make sense without a proper ASN1 compiler, because these things are really hundreds of pages in the standards, and it's you have to automate, or else you won't get anywhere. These are not your typical IETF protocols. We used to joke that these were not defined so you would have fun to implement them. There are different reasons to that things are done there this way. So this is how it looks like, and for 2G and 3G, this is how a simple signaling flow would look like. So you can immediately see how we can map this to SIP. So these technologies evolved naturally, so they're not really different from what you would typically do. Your phone would come up, would connect to the network, use the connection management layer to establish a connection with the network, then send setups and code, we would receive call proceeding and alerting and so on, and then establish that call. But now in LTE, obviously we have something else, because in LTE we don't have anymore this secret switch layer. We don't have a way to transport GSM layer 3. There were many efforts to do that, to actually just take that and put it over IP and see how it goes. But in practice, it's just too complex, and then you're still stuck with the old architecture. You're still going to have to use intelligent network and so on for telephony. So these were largely unsuccessful. Then you have the next option, secret switch fallback. So whenever you have your mobile device receiving a call or making a call, then just do a handover to 2G, 3G, handle the call, and then go back. This is bad because obviously you're losing the good LTE connection. And it also puts a lot of signaling strength on the core network, as you have then lots of handovers like that. Another option is to do simultaneous voice and LTE. So then why disconnect from LTE? Keep it connected, but also connect on 2G and 3G. This, of course, is also not good because you need then two radios active in parallel, so your battery goes down twice as fast. Lately we're making progresses on the battery lives, but still I think you're not happy with your smartphone's battery life today. So this is also not practical. So then the proper solution should be voice over LTE, which is basically IMS. So we have an IP connectivity network, and then just to do SIP and RTP and so on, and use an IMS core network to provide telephony. Now, sounds a little bit simple, but there is a gap between the secret switch and packet switch solutions. Of course, today, if you have LTE, you already know this, that most of the operators are just doing secret switch fallback and just make a call and see if you're still on LTE. If you're not, they're not really having an IMS core network to do telephony. Then, IMS maybe it's still a little bit of a part of the problem because you might still have operators that are saying, well, we don't have this yet, it's not yet deployed and so on. But come on, we already have it in a lot of fixed networks. Mobile is always a little bit in front, so that's not really the big issue. The big issue, I think, is this voice call continuity, because you can't just deploy the two networks and then, deal with the issue that your mobile subscribers are walking out of LTE and, okay, call is broken, you have to reestablish the call. How do you do that? How do you integrate between your legacy and the new architecture? And there is a big solution for this, typically in the 3GPP's way of doing things, adding more functional elements, more interfaces, more protocols, and so on. So there is a solution to do this with single radio voice call continuity, but this is quite complex. requires MSC upgrades. So these are, 20 years old equipments that now we say, okay, you have to add an interface to this thing, or you need an upgrade. Nobody wants to invest in those anymore, while they're also investing in IMS. And you have to interface between MSC and IMS. You have to interface between MSC and the mobility managers, so MME, SGSMs, and so on. So they cooperate during a handover, and the new node is going to wait for you and know exactly to immediately reestablish the call. So you're not going to have interruption in the voice flow. It's still very hard to get rid of this component, with the new architecture, we are actually adding a lot of requirements. This is how it looks in practice. So if you have here on the bottom the new architecture, this is LTE, could be actually just as well Wi-Fi. So if it's Wi-Fi, instead of having here the LTE base station, I have a Wi-Fi base station. So it's actually the same thing if you want. Of course, LTE provides you guaranteed QoS and so on, but in practice, Wi-Fi works very well for voice over IP. So here on the bottom you have the packet switch only network, and on top you have the circuit switched one. So you see you have to integrate and make an interface for coordinating the handovers between the legacy MSC and the new mobility management entity. And then, of course, you have to anchor everything in IMS. So every call that goes through your legacy network has to be anchored in IMS, so that when you do the handover, you know how to hook it up with the other leg. So this is how 3GPP puts it. They are introducing new functional elements, a service centralization and continuity application, which is very nice because it just works on top of standard IMS, but 3 new components, then you have new interfaces, then you have notification on MSC, so it looks pretty nasty. So our crazy idea was, well, if we have to modify the MSC, then why not go really crazy on that and really do it the proper way? Forget about SS7, forget about Camel, IM, and so on. So drop all that legacy. Drop also SRVCC, because there are so many new nodes in the network. Why should we go for that? And instead concentrate on a single voice core. So not having any more to deal with an IMS and then integrate it with your legacy soft switch and interfacing and so on, but keep investing into one single voice core network. Then we have already voice over LTE and Wi-Fi basically done for us, because IMS supports that. And for 2G and 3G terminals, well, all we have to do is to translate this between GSM layer 3, the core control part, and SIP and IMS. So we are introducing a new type of MSC, if you want, and instead of all this SS7, IM, map, and so on, we directly translate between what the mobile phones are talking and SIP and diameter and RTP and so on. So basically, we're making in our demos that every 2G and 3G phone has in the MSC a simulated virtual IMS user endpoint. And when you are touching the network, that virtual endpoint is being registered to IMS, so we know where to find you. So simple standard IMS technologies. So maybe I didn't time properly my slides, so it's better if I show this first. So this is how it looks in practice. We have the MSC simulating IMS user endpoints, and all the legacy is reduced here to the radio access network, and then it just looks like a normal IMS client. For LTE, you're coming with natural IMS clients. Oh, I'm talking a lot of IMS, but probably you'll see, hey, we don't really need IMS. So if you have just a SIP and so on, you don't want to align with IMS, it's also fine. The same technologies, the same principles would be just as useful. And because you still have to integrate with SMS centers and so on, there are well-defined gateways in IMS, for example, to do that. So just going simple, you don't need to keep the whole legacy for the MSC and so on. So as advantages, First of all, we have just one single voice core network, like I said. So you have common provisioning, common management for for both your legacy and new engine telephony solutions. The whole architecture is simplified, and we are keeping everything, all the legacy, just isolated in the radio access network. It's aligned with the new concepts for multi-access. We think that from next year and so on, actually, the new thing that is going to come up is that you're going to have LTE and Wi-Fi and so on, or 3G and Wi-Fi in parallel connected, and then you can select which flows to send where. It's still very complex, but anyway, this solution is compatible with that and works very well with that. SMS are trivials, so the whole thing's, for example, voice call continuity is very simple. It's just a simple handover. I don't need a new component. I just need to do a handover between two IMS user endpoints, and that operation is also very well defined. Somehow in the middle, I don't know if I should call this an advantage or disadvantage, is that, we don't have supplementary services which do just that, right? So, call on hold, whatever, voicemail and so on, then that's gone if I drop the whole platform. Also gone is the whole prepaid things. But on the other side, all of these things are also implemented in IMS. So if you just have MNTEL, RCS, ICS, or however you want to call your telephony application on top of IMS, that would be a replacement for all the supplementary services. Risks, of course, it has risks because it's actually hard to replace today's equipment with that. The interfaces are a little bit difficult, so we need some very smart load balancers to select between these nodes. Another point is that these base stations are not always standards aligned, because in some cases for 2G there were no standards for how to transport these things over IP. But still, you can go equipment by equipment, in the end you can do this. So this is the solution in a nutshell, and you can see it, we have a booth there outside, and you can see the solution working, you can maybe look at the traces and so on. I think we're demonstrating now with a 2G cell, also a 3G one would be possible. I'm not very sure if we're showing everything on the Raspberry Pi, but it certainly is possible. We couldn't get in time to put also IMS directly there. We had some small routing issues in here and so on, but it is it should be feasible. And we have different demonstrations like that. I don't know. It seems that this using Raspberry Pi is really excited a lot of people. So we're showing, for example, that with one LTE femtocell and running OpenEPC on a single Raspberry Pi, we can do some decent breakout. It doesn't have any practical, purposes to say, hey, we are the only core network that is USB powered. But it kind of shows that, hey, you can put this technology in your home router, you can put it in the cell, and so on. So basically, we can, in the future, make some very flat core networks and really push them to the side, and with some, just simple standard C code, we can handle everything very efficiently. So that's it. Thank you for your attention. If you have questions, I'm open to them. I hope I didn't run too much over time.
No, you are just in time, just a bit late, so we have time for questions. Thank you, Dragos, first. James, of course.
Yeah, Dragos, that was great. I enjoyed that. I'm kind of curious as to where you're going to go with this, who you're going to sell it to, and you clearly had, you agonised over whether to open source it or whether to take a more commercial route. Now you've decided to go commercial. What are you going to do with it?
Yeah, that's the right word, agonizing, because you never know if it's the right thing. It's we appreciate fully the open source part of these things. I mean, I actually got a PhD on talking about open source in telecommunications. So we would love to go in that direction. Otherwise, this is an idea. I mean, yeah, it's a competing environment. You can also implement this very simple on yourself. It's not such a. I think it's more about, hey, yeah, it is possible. So this is my message, so to say. We're not really targeting the big established operators, so we don't think that whatever AT&T, T-Mobile, and Vodafone and so on will ever hear about this. But we do get some very interesting questions and requests from operators from, I don't know, smaller countries or Southeast Asia and so on, which are more practical in what they do. Yeah? So from their perspective, they're not really looking at IMS because of LTE, because they're not yet deploying LTE. But they're more practical in costs and so on, and they're using already Kamailio and so on. So they already know these concepts, and they're coming to us and they're saying, why should we still invest in the legacy? Yeah? So these ideas and so on, they're coming actually from that part of the industry, from these guys that were looking for more practical solutions than these big racks and so on, because they played with Kamailio and say, hey, it's possible, so make the link in there. Yeah, for the business side, yeah, it's actually quite difficult to deploy it in the market, as you already have these equipments, deployed. But then you have a lot of networks, upcoming networks. You have things like OpenBTS, OpenBSC. Yeah? So you practically can, with open source, build your own mobile network. Yeah, these are the targets that we're going for.
Other questions?
Daniel, can we go there?
So this looks like a great idea, but my worry is that it's not what the IMF specs say, and so you're sort of dividing into the MSCs that do real IMS and these sort of custom MSCs that sort of going down the path to vendor lock-in. Are you going to be doing anything with the 3GP standards body to say, look, our idea for an MSC is better, put this into release 13?
Well, it's yeah, so definitely there is no standard for this, and yeah, but that never stopped us, So, actually, after implementing everything, we hate the standards with a passion,
I know what you mean.
Because on this page they're saying true means 1 and 0 means false. On the next page, true means 0, and for the same information elements, and the other way around. So then, I don't know about the standards, if we should actually standardize this, or it should just come naturally. I think it's easier if it just came naturally without a standard. The moment that somebody needs some interoperability and so on, standards will be made. Myself, I'm coming a little bit from the research part of the industry. So if I would represent, take the Fraunhofer focus phase, I would tell you that Fraunhofer does not invest in standards. It's not that we don't need them, but we're not, basically we do not make our R&D dollars with writing standards. These should come, should be funded. Who should fund this? Operators, major vendors, and so on. But then talking about this small spin-off company, yeah, it does make sense, but somehow I think we're still very small to actually go and fight the politics inside 3GPP. So I'm hoping that, with these ideas, some of the operators that we're talking with and so on, or maybe others here in the room, that if they like this idea and they want to deploy that and so on. And by the way, open source is not out of the question entirely, so it is an angle in there that we're just trying to see what's the right thing to actually have everything well funded. So if we find the right forum, if you want, the right set of people, I'm really open to go to the standards and do this. So we had the same experience having practical ideas for ADSFs and so on. People saying, hey, you don't need super complex SyncML over HTTP and so on just to tell me to do a simple handover, because I have to implement this in a simple modem. Now, what are we doing? Are we going to teach the modems HTTP? It's a little bit too much. So we tried this, and a lot of people they told us, hey, let's go with this to the standards, but